much, everyone, for inviting me for this great opportunity. I'm happy to be here and give this lecture. As I said, I wish I was in a better situation to prepare the things, and but now I tried my best. I hope you would enjoy the lecture. I assume that you all are students, and of course, my lectures usually are interactive, and in the online sessions, it's a little bit difficult and tricky, but please interrupt me if you have any question or comments, because usually in an in-person class, we discuss the things through the slides, but I suppose it would be challenging through the online slides. So in this presentation, I tried to explore the sensing technologies for the built environment with a focus on geomatics. I tried actually to simplify the content as much as possible, as I wanted to explore the main component in this technology and how they evolved and how they impact the human life. So I hope it can, the main point can be delivered, but please, as I said, interrupt me if you have any comment or question. So in this presentation, first I introduce the sensors. Of course, it's about sensor technologies. So we start with sensors and how how it works and what type of sensors do exist there, and different relevant topics about the sensors, and then we explore some applications while we discuss the relevant aspects for the trends of evolving the sensor technologies. And we also mention about the future directions and how it goes, where it goes in the future. So the sensor technology. But first about sensor. Sensor is a device. It's something that measures a quantity. So there are different types of sensors available in different forms, different shapes, different size, and all I mean, the purpose of using these devices is to measure something. To always we have some physical entity in the real world, and we try to quantify it, and the device actually generates some output as an electrical signal or optical signal. So this quantity can be sound, can be heat, can be pressure, or light, or motion, distance, or humidity, and any entity that we may imagine to measure in the real world. It would be possible to use such devices to quantify it and quantitatively measure the value for it. So it's all about measurement and data collection. So for any subject that we specified here, we get some data. Through time, actually, there are progress. Actually, the devices, the sensors, actually, miniaturization happened, and it means that the devices are getting smaller and smaller with the better performance and better capacity. Another trend, so I'm talking about the key trends in sensor technology. So another trend that we had through time historically is digitalization. So now all the sensors actually are digitalized, provide some digits, some quantitative measures. And another key trend is the integration. So we have for many applications, we have a couple of devices, a couple of sensors integrated together, fused together for a certain application. So these are three key trends in sensor technologies. But let's see how it works. So there are different types of sensors. For example, we have light sensors. It's obvious, it measures the degree of the intensity of light. There are a group of proximity sensors that it's actually contactless sensors without a physical contacts detect an object, the presence of object or movement of object or distance, whatever. So it can, for example, be ultrasonic sensors, optical sensors. It may use infrared or LiDAR or radar and many more. We have temperature sensors, we have humidity, chemical sensors, many more. So traditionally, we saw the weather, the sensors in weather station to collect the weather data. We have them in the total station, the surveying cameras. We have even in speed cameras using this technology, radar technology, for example, LiDAR technology to measure the speed. So in different ways, they affect our life. Even in our smartphone, it has a couple of sensors for different type of sensors. And every day, uh, many more are added to these smart devices. In the health, there are many health applications to measure different quantities in our body regarding the health management. So we have many type of sensors like this. Or I'm sure you heard about the autonomous vehicle, the self-driving cars. Actually, it's an example of integration of sensors. So in the self-driving car, there are many type of sensor like radar, LiDAR, even cameras. So these kind of sensors are integrated together to make it possible to make this car self-driving as a self-driving car. So in geomatics, actually, we know all that remote sensing is evolved a lot from sensing technology. We have actually a lot of satellites with different sensors, with different generate different type of images with different spatial resolution, temporal resolution, and with the different technologies like active technology or passive technology. For example, here you can see a LiDAR type of images. And the base of this remote sensing technology is a kind of proximity or contactless sensors that use electromagnetic reflectance as in different ranges of this reflectance to measure the quantities in different applications. So in geomatics, these sensors can be on satellites traditionally, but they can also be used in the built environment in cities. For example, we have radar or LiDAR sensors to detect objects in the cities, in the streets. For example, we have some applications there. So we have different platforms that we can use these sensors, but all actually can provide some geospatial data that can be used for geometric applications. They can also be attached to drones. So it actually shows the evolving technology in the field of geomatic that use the sensor technology coupling with the other technologies to provide some applications. So advances in sensor technology actually improve our capacity for data collection. That's obvious. So new sensors and new capacities actually provide the possibility to collect more data, uh, precise data, and more accurate data. But what else? There are some concepts that in the last decade or 2 decades actually have been progressed, like citizen science or crowdsourcing, that actually use human, all of us, as a source of information. So we can contribute to, for example, use our phone or any devices that we can use here to provide some data. So it is kind of advances in sensor technologies because we help to collect such data. The um, aim behind these advances is to improve the data collection. And this is kind of influential concept that has been used in the last decade, especially to given a lot of, a smartphone and such devices capable for collecting many data. So we can use to provide, to improve data quality capacity. But the challenges that we have here, especially specifically for geomatics or geospatial science, is that given these diverse type of sensors and the a lot of data resources available, we are dealing with big data, because it's not like only improvement in the precision or spatial resolution, but it's also improvement in the temporally. So we have like more frequent data, and it means that the size of data is getting bigger and bigger. So another challenge is communication. We have like different sensors, so the data should be delivered or the sensor should be communicated for many recent applications. And another one is data processing. We need to process this data. So I just put these three key terms here because I want to, I believe that these three key terms are important to understand what is behind this technology and how these technologies are evolving in the field of geomatics. So let's see what I mean. So we know that, yeah, especially in the last 2 decades, we have a good capacity of high performance computing and cloud computing. A lot of good resources are available for any kind of computations. So that is for dealing with, processing big data. But there is one influential concept that is important a lot here in using sensors and especially for the field of geomatics. That is the Internet of Things. This concept actually make it possible to simply address the communication challenge. So it's a simple concept. Each device can be connected to the internet, and then when they are connected, they can communicate to each other and make a kind of network. So it really makes the things easier and provides a lot of potentials and capacity for a lot of applications. And another influential thing that has been evolved, especially in the last decade, is artificial intelligence. So by improving our capacity in computation, we have the algorithm for machine learning and deep learning improved a lot, hugely improved, and they offer a lot of application to process the data, to understand the algorithms in the data. So we will discuss a little bit on either of these terms. So about the Internet of Things, it's, as I mentioned, it's easy. Each device is connected to the web, and then they can be communicating to each other. They can exchange data and make a kind of network, or there is a term like sensor web, for example. We just put the sensors and devices on the network, so make it possible to communicate with each other and exchange the data. And especially for the one of the trends that I mentioned, for many applications, we need the integration and fusion of different sensors together. So this IoT technology actually plays a very important role to make it possible here in this case. And one of the very important capacity that we have by bringing IoT technology here is to real-time or near real-time monitoring of the measures that we have here. So we can continuously monitor an entity, a physical entity that we are interested in. And of course, this capacity provides make it much easier and more efficient to maintain the devices and the whole technology. So this artificial intelligence actually is a kind of learning algorithms that can be used effectively to gain insights from the data and understand the patterns from the data and classify or predict the data. It plays very important role in the field, uh, in many disciplines, including geomatics and using sensor technology. And by having this artificial intelligence integrated, we simply convert the sensors into a smart sensors. It's very important, actually, an important trend that we have, because these smart sensors actually has the capacity to learn the things and think, and also make the results that the sensor generate more efficient. So it's not like a simple device that collects some data. It has the capacity to learn, for example, to understand the best way to collect the data, how to reduce the noises, for example, or what exactly should be collected to make everything more as efficient as possible, or detect the failures if there is any failing in the data. So it's changing a lot the capacity of these sensors in many applications. So it can be coupled with kind of processing algorithm, and therefore, instead of raw data, it can provide some interpreted information. So it's very different here when we have the smart sensors in many applications. And of course, we would say that the behavior is smart, so they can be smart in many aspects, as we mentioned here. So in geomatics, actually, we usually have some the concern is, like, for example, we have a good spatial coverage, like dense spatial network. It's one aspect when we want to, for some application, that we want to use the advantage of sensors, for example, to monitor some an entity. So the spatial coverage is one important aspect. And then for many applications, the temporal coverage, if it can be a real-time coverage with high temporal resolution, is another aspect that is possible now with the advances that we have in the smart sensor technology. And it can be integrated easily with the other data streams. So it's like a kind of fusion in the different resources of data. And that's why it can easily be used for scientific data processing. So it can automatically generate some outputs that have the values, would have scientific values, and can be directly used, for example, by for example, by managers for making decisions, or automating the decision making, and so on. So we have like a lot of advances in visualization technology, given the advances in the sensors in geomatics. We have a lot of workflows and procedures automated, and we have the algorithms and workflows for good interpretation of the collected data by sensors. So we can simply say that we would be able to develop a smart system. So in a smart system, as I said, we have, I believe, three components are important: the sensor technologies, the communication technology, and the data processing technology, which is, for example, machine or deep learning algorithm. So by having these three, we can simply provide a lot of application and develop a lot of smart systems in any environment, including built environment, like the smart cities that will go through it. Another important thing that we should not forget about the geomatic-based smart system is the location-based services or positioning system. So that is another component that is very important, as it's part of the many devices that we use here. So these data are important. Even indoor positioning are developed now, and we can simply use the same as what we have as GPS outdoor. We can have such technology to use the location-based services indoors. So the advances actually are happening in either of these technologies together. So we have some studies that only work on at enhancing the sensor technology or an Internet of Things or developing machine learning algorithm. But there are also some trends that try to integrate these key technologies together for some applications or for some developing some system that generally we can say it's a smart system. So if you want to um, just review the technologies, quick review for in Geomatic, we have like a space for like satellite images, drones, and different land-based sensors available here. And there are some other technology, as I said, we have navigation sensors, we have radio frequency sensors, and the other sensors that measure the quantities can be either passive or active. So one of the most influential technologies that have been, changed a lot in recent years, many applications, is the LiDAR technologies. So um, so these active geomatic sensors is radio detection or radar, radio detection and ranging that use a long wavelengths microwave reflectance to measure, record the amount of energy that has been emitted from the sensor back from the train, from the object that we use. And LiDAR technology is kind of the same technology, but it uses short wavelength laser light. So it's more efficient, it's much more efficient in terms of precision and the capacity to use to measure the things and objects in space and time. And sonar, actually, it's obvious that it uses sound signal. So all of these technologies are active geomatic sensors. As I said, LiDAR is one of the most influential technologies in recent years. So there are a lot of development there. So it has been used in many direction and many applications. As I mentioned, even in the self-driving cars, in the street, in the built environment, we have the use of LiDAR. Even for speed cameras, we have now the sensors based on LiDAR technology. So it can actually be used here. Let me just show some application. So first of all, laser generates some optical pulse, the way that it works. And pulse is reflected off an object and returns to the system receiver. So that's the optical pulse is generated, and the reflectance of that pulse is received by the system. And then there are some sensors that try to measure that signals that have been received, and the time measurement. So we have like different pulse, and the time between each pulse is also measured. So the measurement can be interpreted as the distance, one of the important information that we can have from this kind of LiDAR technology. So there are multiple returns can be measured for each pulse. So the intensity of the data is so high, that's why it provides a lot of capacity for this. You can see an traditional example of LiDAR for mapping, 3D mapping of the object. as you see in these pictures. But another applications is to detect vehicles in the built environment, in the roads, for example, uh, that we can detect pedestrians on the street and vehicles. So it can also be used in the cars to detect either pedestrian and vehicles. So to have actually to make it possible, it's not only the sensor technology, but they are coupled with the data processing technologies, and also the probably the Internet of Things or the other communication-based technologies to make it possible to have such applications. So we have such capacity, such algorithms based on the LiDAR technology right now that follow some workflows how to do that. It's like that you know, the structure of data is not that difficult, that complicated. It's like a lot of measurements that you first require to filter out, for example, the background. If the object is here, like this pedestrian, you need to filter out other measurements that are not relevant, and we call it background. And that's why then you need to select the region of interest that you need to focus. And these region of interest are going to some machine learning algorithm for classing to understand whether, for example, is in this case it's pedestrian or not, or whether it's vehicle or not. And that if that is classified accuracy, then it can be used to track that pedestrian, because the trained algorithm can follow, can track the object there. So it provides a very good way of providing the data and monitoring the object that we are interested in. So there are some different algorithms for clustering, and this in this case, for example, I just wanted to show how in a study that they provided how the data looks like when the object, the pedestrian, are getting away from the LiDAR sensor. Still, when it's get away like 26 meters, in this case, it was possible to detect the object. So it shows like the capacity of the algorithm. And the algorithm behind detecting this thing is based on density-based spatial clustering application. That is not actually very complicated concept. And we can use also train like artificial backpropagation or artificial neural network based on the measures that we have from LiDAR, like two-dimensional distance, direction, and total number of points to cluster, to classify pedestrian and discriminate pedestrian flow from vehicles. One of the recent recent trend that we have to integrate all of these things is the concept of smart cities, that I think it's relevant to the use of this geomatic technology in the built environment. So in smart cities, first of all, we use these sensors technology, Internet of Things, to communicate between these technologies and process the data and make everything smart. So as I discussed earlier about the smart systems. So there are some key aspects like connectivity, for example, one of the main key aspects in developing a smart city. A smart mobilities, for example, is one important aspect. So mobility in cities become a smart mobility when we couple this sensors technology with the positioning, you know, a couple of um, sensor technology like positioning technologies and some measurements that we have for mobility. So it make if we have like a perfect smart mobility it makes the accidents and facility uh, accidents in the road zero, or carbon footprint zero, and the level of stress in the cities zero. So that is triple zeros that we have when we have a perfect smart mobility in smart cities. The positioning, as I mentioned, one of the key aspects that is very important to develop such smart cities. So the exact location, outdoor and indoor, uh, should be measured. There are technologies for indoor positioning system that have been developed in recent years, and they showed very successful. So in the locations that we don't have access to GPS satellite positioning systems, there are ways to couple, to integrate the uh, things and some solutions like wireless solutions, Bluetooth, and using other sensors on the smartphone, for example, to generate um, the positioning indoor, or navigating indoor. Uh, Self-driving cars, as I mentioned, use many of such sensors together, and it's an example of again, putting these three key things together: integrating the sensors, communicating with them, and processing the data. So it's like artificial intelligence play an important role to make it possible. So you see, there are many sensors, and some sensors use lidar technologies. Some of them are based on just cameras and vision that we have, so you can see that integration of all of these input can make it possible to train a deep learning algorithm to make it possible to you know uh, make the self-driving car available. So for example, here you can see how we can avoid the collision in a street. So it's exactly the same procedure as we had for detecting pedestrian or vehicles. Here, one clustering algorithm is integrated here that detect the vehicles using a LiDAR technology, and then when you detect the object, it's possible also to measure the distance, and that's enough to avoid any collision. So there are many uh, aspects or horizons for smart cities. Some of them, like Internet of Things, we still need to develop, but it can make many applications like business, agriculture, environment, governance, and so on smart. Uh, so we have here like the main, um, as we discussed, smart mobility and uh, smart people. It's possible. It's the main component that we would implement in smart cities. Um, so the reason that it's possible to have like a smart city is that because today uh, 3.6 billion people live in cities, and by 2050, 75% of the world population will live in cities. And right now, actually, more than 80 billion connected objects already there, and it's growing exponentially. So we already have the things to make it possible to make all the aspects like a smart mobilities and all the other aspects that we discussed possible. So implementation is available and feasible now, right now. And for example, just 20 years ago, we didn't have any term like Internet of Things, but in 2015, we have 6 billion of devices worldwide. In 2030, we have over 100 billion of devices that are connected. So it's growing really uh, exponentially. Um, we have other application. I tried because of the time. I tried to just pass it quickly, but it just shows some capacity of like technologies like LiDAR for example, here for trafficking system, how the connected infrastructure sensing can provide high resolution traffic information in the smart cities. So it's based on, the LiDAR technology, as I mentioned, is so influential, and the connected vehicles. So it would be possible to, uh, you know, uh, to provide this trafficking information given different objects, as you see, even if it's complicated, like if different type of vehicles, bicycles and pedestrians are there, by when they are connected to each other, the vehicles are connected, and there are some LiDAR sensors to detecting the objects. It would be then possible to just make it develop a kind of a smart system for trafficking and make it efficient. This LiDAR technology can even detect objects in different lanes in the streets. And usually for this, there is like a kind of a minimum area rectangular circulation. That is the way to identify the objects like vehicle, but I don't want to discuss the details behind it. I just wanted to show that there are uh, implemented and successful procedure to use this capability for such applications, that we use raw LiDAR data for detecting object, clustering object, and then tracking the object. In the other application, for example, this is a study that I was involved. We use some sensors on the bodies to like accelerometer and GPS data to identify the physical activity by humans. The output of such data could be such maps like the density of people or running in the city or biking in the city. Uh, for the future trend, actually, it's the last slide. I believe that we would have um, this a smart key term even more influenced on our life. You know, we have robotic technology that use this a smart system, and I believe in a near future we would have more uh, a smart way of controlling this data collection. Just imagine that such drones, now we may have a sensors. It can be coupled with some smart algorithm, and then can be controlled by human. But just imagine this is a kind of flying robot, and it is smart enough to go by its own, collect some data, make decision where to go, how to collect the data, and even can communicate with the other objects or humans. Human can call a system and can response this drone, the smart drone can respond and go there and collect some data. It's like a kind of flying robot that plays as like a police in accidents, for example. So in future, I think there would not be such surprise because the technology is there, and we just need to integrate these things to provide a lot of capacity for nicer applications. And we know that there are a lot of investment for developing robots in many disciplines, many applications. And uh, this would not be happening if we don't have like such sensor technologies to those three key terms that I mentioned, like the sensor technology, communication technology, and the artificial intelligence. Integrating of these three main components would make it possible to make the things as smart as possible. Thank you very much for your attention. Please, if you have any question, I would be happy to address them.
Thank you very much.